Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Imagine a night so silent and still that you can hear your own heartbeat as you stare up into the black velvet sky. A sky untouched for millennia, save for the faint trails of comets and the occasional glimmer of a satellite. Now imagine a future where those distant pinpricks of light aren't just stars, but colonies, habitats, entire civilizations, human footsteps stretching out across the solar system. It's not a scene from a science fiction novel. It's a possibility that right now is slowly moving from dream to design. For thousands of years, humanity's relationship with the cosmos was that of the curious observer. Ancient civilizations, Egyptians, Babylonians, Mayans, built monuments and calendars aligned with the heavens. But it wasn't until the mid-20th century that we truly broke free from Earth's embrace. When Yuri Gagarin became the first human in space in 1961, it wasn't just a Soviet victory. It was a species-wide awakening. And when Neil Armstrong and Buzz Aldrin left their footprints on the moon in 1969, humanity collectively realized space was no longer just to be studied, it was to be explored. Yet astonishingly, after Apollo 17 in 1972, no human returned to the lunar surface. For over 50 years, the moon remained untouched by human hands, a ghostly relic of an era filled with ambition. What caused this pause? The answers are complex: political shifts, economic constraints, shifting public interest. But today, something extraordinary is happening. A new space race is underway, not between superpowers alone, but between nations, corporations, and visionaries determined to carve out humanity's future beyond Earth. The Artemis program represents the spearhead of this new era. Backed by NASA and international partners like the European Space Agency and the Japanese Space Agency, Artemis aims not just to visit the moon, but to stay. Imagine a world where humans live and work on the moon for months at a time, extracting ice from its permanently shadowed craters to make drinking water and rocket fuel. Picture them using three-dimensional printers and lunar regolith to construct shelters, laboratories, even roads. Artemis is not about proving we can go back. It's about proving we can thrive. And it's not just government agencies taking the lead. Private industry is rapidly becoming the backbone of space exploration. SpaceX, founded in 2002, set out with a radical goal: to make life multi-planetary. Today, its Starship vehicle, taller than the Statue of Liberty and capable of carrying up to 100 metric tons of cargo, stands as a game-changer. Built for full reusability, it aims to lower the cost of reaching orbit so dramatically that space could become accessible to millions within decades, not centuries. Imagine the future first settlers on Mars standing under a salmon-colored sky, watching multiple starships descending from orbit like ancient gods returning to the Earth. They would carry not just people, but greenhouses, laboratories, communication arrays, and the seeds of a new civilization. Elon Musk's vision of building a city of 1 million people on Mars by 2050 may sound ambitious, but consider this. In the early 1600s, Jamestown was a fragile outpost on a wild new continent. Today, North America is home to over 500 million people. Expansion, when combined with determination and technology, can happen faster than we often imagine. But rockets and colonies are only part of the equation. Propulsion technologies are undergoing a renaissance. Nuclear. Thermal propulsion, first seriously studied during the NERVA project in the 1960s, is seeing a thrilling resurgence. Unlike chemical rockets that waste precious fuel fighting gravity, nuclear thermal engines use the intense heat from a reactor to accelerate hydrogen, producing thrust more efficiently than anything flown today. With it, the journey to Mars could be reduced from 9 months to under 4, an advantage that dramatically lowers the risks from cosmic radiation and microgravity. NASA and DARPA are jointly developing a prototype engine, and if successful, it could become the new workhorse for deep space travel. Meanwhile, other propulsion concepts once relegated to science fiction are edging closer to reality. Solar sails, driven by the pressure of sunlight, could one day ferry lightweight probes across the solar system without a single drop of fuel. Plasma engines like the Vasima system offer continuous, high-efficiency thrust for long-distance missions. And experimental ion drives, used on missions like Dawn and Deep Space One, have already proven that slow but steady acceleration can accomplish astonishing journeys, reaching asteroids, moons, and even dwarf planets. Beyond vehicles and propulsion, humanity is also reimagining the very idea of life beyond Earth. NASA's Lunar Gateway, a small space station intended to orbit the Moon, will serve as a staging point for lunar landings, scientific research, and missions deeper into the solar system. Think of it as the International Space Station's more adventurous sibling, hardened against radiation, designed for the harsh void of cislunar space, and capable of supporting human presence far beyond low Earth orbit. As we set our sights beyond our blue planet, new challenges loom: cosmic radiation, bone degradation in microgravity, psychological strains from isolation. Solving these will require innovations in biotechnology, artificial intelligence, and habitat engineering. Advances in closed-loop life support systems, such as hydroponic farming and atmospheric recycling, will be crucial. Companies like Bigelow Aerospace have even developed expandable habitat modules that could provide spacious, inflatable living quarters in space or on planetary surfaces. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. With every new subscriber, we move one step closer to becoming a vibrant community of cosmic dreamers, people who dare to look up and imagine a future beyond the clouds. Just imagine. In a not-so-distant tomorrow, humanity could be a multi-planetary species, with settlements on the Moon, Mars, and even floating cities above Venus's thick, turbulent clouds. The spark of exploration that first led us across oceans and deserts will carry us across the solar system and beyond. Picture yourself aboard a spacecraft, hurtling through the void. Outside your window, a vast, lifeless landscape stretches. Beneath you, the barren red plains of Mars. The silence is profound, broken only by the hum of the ship's engines. Your mission isn't just to visit, it's to stay, to build, to create a new world. You're part of the first generation to venture into the harsh unknown, to plant roots where no human has ever set foot. But getting there isn't the hardy part. It's surviving once you arrive. The next great leap in space exploration isn't just about getting to Mars. It's about turning that inhospitable desert into a home for humanity. Mars isn't a lifeless wasteland, but it's far from welcoming. The air is a thin, carbon dioxide-laced atmosphere. The temperature drops to -100 degrees Celsius at night, and fierce dust storms can blot out the sun for weeks. Any long-term presence will require remarkable ingenuity, technological mastery, and a relentless drive to survive. NASA's Mars Sample Return mission, scheduled for the late 2020s, will bring back Martian soil samples to Earth for study, providing the first real answers to questions about life on Mars and the planet's potential to support human colonization. But sending samples back is only a small piece of the puzzle. The real work begins when astronauts set foot on Martian soil. Imagine arriving in a sleek, self-contained habitat. The walls are lined with green plants, their leaves quivering as the air filtration system hums quietly. The oxygen you breathe is recycled from the Martian atmosphere. Water is precious, but thanks to advanced technologies like the MOXIE, Mars Oxygen ISRU experiment system, you can produce oxygen from the planet's CO2-rich air. It's not perfect yet, but each experiment brings you one step closer to sustaining human life on Mars without relying on constant resupply from Earth. But even with these innovations, survival on Mars will require more than just basic living conditions. Astronauts will need to grow their own food in Martian soil, harness solar power, and protect themselves from the unrelenting radiation that bathes the Martian surface. There's no magnetic field on Mars to shield its inhabitants from cosmic rays and solar radiation, which means habitats will need to be buried beneath the surface or shielded by thick layers of Martian rock or water to ensure long-term health. However, Mars won't be the only target for human exploration. The Moon is not just a stepping stone, it is a treasure trove of resources that could fuel humanity's expansion into the solar system. The lunar surface holds vast quantities of water ice, especially at the poles, which could be used to produce oxygen, water, and even rocket fuel. NASA's Lunar Gateway will be the launch pad for missions to the Moon, but it will also serve as the staging point for further deep space exploration. In the coming decades, lunar mining may become a key industry, harvesting water ice and valuable metals such as platinum and rare earth elements. This could help sustain missions to Mars, build space stations, and provide resources for a growing space economy. The lunar surface offers a unique opportunity to experiment with building infrastructure off Earth, from the first permanent human outpost to the first fully functional, self-sustaining habitats that could one day become the model for human colonies on other planets. But what if the future of space exploration doesn't stop with Mars or the Moon? What if the true frontier lies not on solid ground, but in the vast oceans of the outer solar system? Jupiter's moon Europa, with its icy shell and vast underground ocean, is one of the most intriguing worlds in our solar system. Beneath its frozen crust, scientists believe that liquid water exists, possibly harboring life. Imagine spacecraft drilling through kilometers of ice to reach the ocean below. Beneath the surface, tiny organisms could thrive, sustained by the heat of hydrothermal vents. If life exists there, even in microscopic forms, it could completely redefine our understanding of what life is and where it can exist. But exploring these distant moons requires a level of innovation far beyond what we currently have. Missions, like NASA's Europa Clipper, set to launch in the 2020s, will study Europa from orbit, gathering data about its surface, atmosphere, and potential for life. These missions will be the first step toward a new era of deep space exploration. Missions that could take decades to reach their destinations, using advanced propulsion methods like ion drives and solar sails. But the true potential of these missions lies in the data they will collect, unlocking the secrets of not just Europa, but all the icy worlds in the outer solar system. If exploring the outer solar system is difficult, what about the stars? The dream of interstellar travel has tantalized humanity for centuries. The nearest star system, Alpha Centauri, is over 4 light-years away. Even at the speed of light, it would take over 4 years to reach it. But what if, instead of waiting for technology to catch up, we could start laying the groundwork for the first interstellar missions? Breakthrough Starshot, an initiative led by Stephen Hawking's Legacy Foundation, aims to send tiny, light-powered spacecraft to Alpha Centauri within a generation. These tiny craft, powered by lasers beaming energy to sails just a few micrometers thick, could travel at 15 to 20% of the speed of light, reaching Alpha Centauri in just over 20 years. While the project is still in its early stages, it represents the first practical attempt at interstellar exploration, a thrilling glimpse of what might be possible within the next century. However, these missions are far from easy. The immense distances involved, combined with the need for revolutionary propulsion systems, pose significant challenges. Yet, the very concept of interstellar exploration forces us to ask profound questions about humanity's place in the universe. If we can reach another star, what will we find? Will we encounter other civilizations? Or will we discover that Earth is unique, perhaps even the only cradle of intelligent life in the cosmos? As we look to the future, space exploration is becoming a truly global endeavor. Nations like China, India, and the United Arab Emirates are rapidly advancing their space programs, launching satellites, landers, and even planning their own crewed missions to the Moon and Mars. SpaceX's Starship is preparing to carry humans to the Moon and beyond, not just for exploration, but for commercialization. Meanwhile, companies like Blue Origin and Axiom are working to build private space stations, potentially ushering in a new era of space tourism and industry. In a way, the solar system itself is becoming a giant, interconnected laboratory, testing the boundaries of human ingenuity, resourcefulness, and collaboration. With each new mission, whether it's a rover on Mars, a satellite studying the rings of Saturn, or a probe diving into the heart of Jupiter, we are pushing the limits of what's possible. Space exploration is no longer the stuff of dreams or distant futures. It is happening now, shaping our world and our species' future. The real question is, will humanity rise to the occasion? Will we build the infrastructure, the technology, and the societies necessary to thrive in the cosmos? Now, imagine the unimaginable, a human settlement on another world, buzzing with activity as engineers, scientists, and everyday people go about their work. It's a world of firsts, a world that humanity is slowly, painstakingly transforming into a home. In the distance, you see the silhouette of a massive spacecraft lifting off, bound for the icy moons of Saturn or the outer reaches of the solar system, and it dawns on you. Humanity's journey is no longer defined by the borders of Earth or even the solar system. It is an odyssey stretching far beyond, into the unknown dark. One of the most profound implications of our journey into space isn't just the technology or the exploration, but the shift in human identity. Once, we viewed Earth as our final home, the cradle of civilization, the only place in the known universe where life could thrive. But now, as we push farther into space, we're coming to terms with the idea that Earth might not be humanity's final destination. This idea, humanity becoming a multi-planetary species, raises a host of questions. What will it mean to live on Mars? How will human societies function in a new hostile environment? What challenges will arise as we transform ourselves into spacefaring beings? Let's start with the question of survival. Space exploration is inherently dangerous. The vacuum of space, cosmic radiation, and the extreme temperatures of places like Mars or the Moon make it an unforgiving environment. But we're not just exploring for the sake of exploration. Humanity is looking to create a sustainable presence in these environments. That means building the infrastructure to live and thrive. For example, on Mars, human settlements will have to be self-sustaining. In the early stages, everything will need to be shipped from Earth. But over time, Mars will need to produce its own resources. That means developing technologies like in situ resource utilization, (ISARTU), which is the process of using local materials to create food, fuel, water, and oxygen. The Mars Society has been working on prototypes for habitats that use Martian regolith, the loose soil covering Mars, to construct buildings. With 3D printing technology, we could one day print entire habitats directly from the Martian landscape, reducing the need to transport heavy building materials from Earth. Building habitats that can withstand the extreme conditions of Mars is crucial. The red planet's atmosphere is 100 times thinner than Earth's, and it's made up mostly of carbon dioxide. Without a strong magnetic field or thick atmosphere, radiation from the sun and cosmic rays bathe the surface, making it dangerous for human life. To protect astronauts and settlers, we may need to dig underground or build habitats with thick walls that shield against radiation. We'll need airtight domes, advanced air filtration systems, and heat-resistant materials that can cope with the freezing cold of Mars nights. Temperatures can drop as low as -130 degrees Celsius. But how do you grow food on a planet where nothing grows? For centuries, we've relied on the natural processes of Earth, soil, sunlight, and water, to grow our food. On Mars, none of these exist naturally. But there are hopeful signs. NASA's Veggie experiment aboard the ISS proved that plants could grow in microgravity, showing that agriculture could be possible in space. Meanwhile, projects like the Mars One initiative envision growing crops in sealed greenhouses, where artificial sunlight and recycled water systems will allow plants to thrive. We might even grow genetically modified crops that are designed to withstand Mars's low gravity, thin atmosphere, and lack of natural nutrients. Growing food locally is key to creating sustainable colonies. Without it, we would be entirely dependent on Earth for supplies, which is impractical for long-term habitation. At the heart of these technological advancements is an even deeper question. What does it mean to be human when you're not on Earth? How will our cultural identities, our social structures, and even our biology evolve in a world where earthly systems no longer apply? The psychology of space settlers will be tested in ways we can hardly imagine. Space is isolating. Mars is no exception. With a trip to Mars taking 6 to 9 months, communication with Earth will be delayed by up to 20 minutes each way. That means no instant contact with loved ones, no real-time updates. Astronauts and settlers will need to cope with the psychological strain of isolation, a challenge that has been studied in space missions, but never on the scale of a permanent, multi-generational colony. In many ways, living on Mars or anywhere beyond Earth will mean becoming something new. The human body will be exposed to low gravity for extended periods, which causes muscle atrophy and bone loss. In the long term, settlers might need to undergo genetic modifications to help them adapt to the conditions of space. Genetic engineering could help mitigate the effects of radiation, promote faster healing in low gravity, and perhaps even help the human body produce its own nutrients, reducing the need for food altogether. The psychological aspect of living in space will be just as important. Space settlements will be closed environments, and the mental health of settlers will play a crucial role in their survival. Over the next few decades, we could see advances in virtual reality, artificial intelligence, and social systems designed to keep settlers psychologically balanced. Artificial intelligence could help manage daily tasks, create virtual environments for relaxation, and even provide counseling. But it will also be a time for humanity to prove that we can coexist and build communities in extreme environments. Overcoming the stress of confinement and isolation may be the true test of humanity's spacefaring future. Beyond the physical and psychological hurdles, space exploration also brings new opportunities for collaboration and conflict. Space law, space ethics, and governance will become as important as the technology we develop. In the absence of clear international agreements, space could become a battleground for resources, influence, and power. Who owns the moon? Who controls Mars? As private companies like SpaceX, Blue Origin, and Amazon's Project Kuiper begin to launch satellite constellations and build infrastructure, the competition for space resources could intensify. How will we ensure that space remains a domain of peaceful exploration rather than exploitation? How will we establish fair and ethical practices in the space frontier? The global community will have to work together to create rules and standards for space exploration, rules that can balance exploration, resource utilization, and the protection of potential life beyond Earth. This will require unprecedented international cooperation. The space treaties currently in place, such as the Outer Space Treaty, will need to be updated and expanded to address new realities. As private companies take center stage, governments will need to regulate and collaborate to prevent conflicts and ensure space remains a peaceful and accessible domain for all of humanity. In this new space age, humanity will be tested like never before. The space race of the mid-20th century was a contest of national pride, but today's space age is one of collaboration, ambition, and possibility. It's a race not for power, but for survival, for discovery, and for the future of the human species. Now imagine standing on the threshold of an era in which humanity is no longer confined to a single planet, but is reaching for the stars. You step outside the first human settlement on Mars, taking a deep breath in, knowing that every step you take in this alien world is a step toward defining what it means to be human in the cosmos. But as you look up, beyond the thin Martian atmosphere, you're reminded that the journey has only just begun. Mars, the Moon, even the icy moons of Jupiter, they are just stepping stones, gateways to the true wonder that lies beyond. The idea of humanity becoming an interplanetary and eventually interstellar species is no longer the stuff of science fiction. It is a very real, very pressing challenge, and it will require more than just space agencies like NASA and SpaceX to accomplish. It will require a global effort, involving governments, private companies, and even citizens, working together in ways that we've never seen before. As we stand on the edge of this new frontier, the question becomes, what kind of future will we build in space? The technologies we develop today will shape not just the trajectory of space exploration, but the future of life on Earth. For instance, the innovations that make long-term space travel possible, such as closed-loop life support systems, advanced energy production, and sustainable food production, could revolutionize life on Earth. They could help us solve some of our most pressing issues like climate change, energy scarcity, and food insecurity. Technologies developed for Mars colonization, like efficient water recycling and carbon capture, could be implemented right here, benefiting life on our home planet. But what if humanity's journey into space isn't just about exploration and survival? What if it's about something much deeper, a way to answer the most fundamental questions about our existence? In the vastness of space, with billions of stars and countless planets, we are forced to ask, are we alone in the universe? If we discover life on another planet, even microbial life, it will change the way we think about life on Earth. It could redefine our place in the cosmos, challenging everything we thought we knew about biology, existence, and intelligence. Consider the implications of discovering life on Mars or Europa, or one of the exoplanets orbiting distant stars. For centuries, we've looked to the stars with wonder, imagining the possibility that we are not the only intelligent beings in the universe. Yet, despite our technological advances, we have yet to find definitive proof of extraterrestrial life. But that could change in the coming decades. Missions to Mars and Europa, along with the study of exoplanets, are taking us closer to an answer. Each discovery brings us one step closer to a reality that could shatter our understanding of the universe and our role in it. But what about the long-term future? If humanity becomes a multi-planetary species, and perhaps even a multi-stellar species, what will our societies look like? The new colonies on Mars, the Moon, and beyond will likely develop their own cultures, their own identities. Imagine the people of Mars growing up knowing they are citizens of a world that is not Earth. The cultural, political, and social structures of these colonies will evolve independently, influenced by their unique environments. We might see the rise of space-based economies, with industries like asteroid mining, space tourism, and solar energy harvesting playing pivotal roles. New forms of government could emerge: space democracies, corporate-run colonies, or even entirely new political systems that are built around the realities of life in space. But as we venture further into space, we must also consider the ethical implications of colonizing other planets. Who gets to decide where we go and how we settle? Should we terraform Mars, turning it into a second Earth, or should we preserve its natural state? What responsibilities do we have to the ecosystems and potential life forms we may encounter? As our presence in space grows, these questions will become increasingly urgent. And then there's the greatest challenge of all: sustaining life in space for future generations. The distances involved in interstellar travel are staggering. The nearest stars, Alpha Centauri, are more than 4 light-years away. To reach them, we would need spacecraft that can travel at significant fractions of the speed of light. Current propulsion technology is far from adequate for such journeys, but advances in nuclear fusion, antimatter propulsion, or even theoretical concepts like the Alcubierre drive could eventually make interstellar travel possible. But even once we get to another star system, we would need to find a planet that can support human life. Planets that might not be discovered until well into the next century, if not longer. Yet, it is precisely this challenge that gives space exploration its sense of wonder and purpose. Every new frontier we reach brings us closer to answers, not just about the universe, but about who we are and what we're capable of. We've always looked to the stars with awe and wonder, but now we have the tools, the knowledge, and the ambition to reach for them. The future of space exploration is not just about visiting distant planets or gathering scientific data. It's about humanity taking its place in the cosmos, establishing a legacy that will last for millennia. The journey will be long, and it will be difficult. It will require sacrifices, innovation, and collaboration on a scale we have never seen before. But one thing is certain: humanity's future in space is as inevitable as it is exciting. With each mission, each breakthrough, and each step forward, we are carving out a future for ourselves among the stars, a future that could one day see humanity thriving on multiple planets, reaching for new worlds, and perhaps even discovering life beyond Earth. So as we stand on the threshold of this new age, the question remains: Will you be part of the journey? Will you watch from the sidelines, or will you take the leap into the unknown, helping to shape humanity's future among the stars? The choice is ours. If you've enjoyed this exploration of humanity's future in space, don't forget to like this video, share it with fellow dreamers and explorers, and let us know what you think in the comments. Where do you see humanity going next in our quest beyond Earth? What challenges and opportunities excite you the most? Your thoughts help us shape the conversation and the future together.